Hello everyone, so in this video, me and my friend from group 4 will explain about Markov chain in genetics. Let us start with some brief introduction about Wright-Fisher model. Wright-Fisher model is the basic stochastic model of population genetics, which is the model for genotype evolution in a finite population. It was named after a British statistician R.A. Fisher and an American geneticist Sewell Wright, and have been known as the center stage in mathematical genetics models. It assumed that this model described the sampling of alleles in population which are degeneration or non-overlapping. Each of the generation is produced from the previous one by independent. It is random matchings. There is no selection, mutation or migration. There are some terminologies from population genetics. First, within a cell there are chromosomes. A particular position of chromosome is called a locus. On each locus of chromosome there are genes. The different versions of a gene on a particular locus are called alleles. It can be summarized as follows in the notation as shown. Mutation is a process that have unpredictable changes in the structure of DNA. The changes of structure in DNA can be deletion of mutations, addition mutation, or substitution mutation. So, in the mathematical model of Markov chain in genetics, there is mutation process. We assume that each gene have probability to mutate. For each gene, the mutation small a to BA occurs with probability alpha and BA to small a occurs with probability beta. Again, we assume that the composition of the next generation is determined by n independent binomial trials. General formula for mutation process from the equation shown, Pj is the probability of getting allele small a and Qj is the probability of getting allele BA, Vj is proportion of small a gene. Besides, 1/2n is the population selecting allele small a after mutation process. The transition of probability matrix is computed according to the binomial distribution as this equation, where the Sn is the number of small a genes in the nth generation among a constant population size of 2n individuals. J is the number of population of small a genes at n generation, which is row, and K is the number of population of small a genes at n plus 1 generation, which is column. The example of mutation process. For example, there occurs the probability of mutation as shown. Then we assume that n equal to 3 and 2n equal to 6. Then, the composition of the next generation is determined by 6 independent binomial trials. The value of alpha beta we put it into this equation. Then by general formula of mutation process, we will get the value of P and Q of J small a genes as in the table shown. Then, from table, we construct transition probability matrix of mutation by using this equation. Then we construct transition probability matrix of mutation by using binomial distribution, and finally, we will get this matrix as shown after getting the probability matrix of 7 times 7. Okay, that's all from me.
Next, I will explain about selection force. What is natural selection? Natural selection is a mechanism of evolution that occurs when the natural environment selects for or against a particular trait. The selective pressure or selective force causes certain alleles to become more common in the population. Suppose we wish to impose a selective advantage for small a genes over capital A genes so that the relative number of offspring have expectations proportional to 1 plus S and 1, which is S is small and positive. The value of Pj and Qj from the simpler half-plot model is replaced by the new Pj, which is 1 plus S times j over 2n plus Sj, and Qj is 1 minus Pj. If the parent population consists of j small a genes, then in the next generation, the expected population sizes of small a genes and capital A genes are as shown below. The ratio of expected of small a genes to capital A genes at the n plus 1 generation is 1 plus S over 1 times with j over 2n minus j equals to 1 plus S over 1 times with number of small a genes in the n generation over number of capital A genes in the n generation. Next, we proceed to graph analysis. In this graph of the transition probability matrix of mutation, we can see that The number of population of small agents at n+1 generation went up and continued to rise steadily when the number of population of small agents at n generation are equal to 0 until 3. However, the trend starts to drop continuously when the number of population of small agents at n generation are equal to 4 until 6. In this following hadith, see that choose well your mate for your semen, as the hidden traits can reappear. The word irq could mean traits or genes, while the word dasas is used to designate the behavior of human traits that skip a generation but reappear in the next. Based on this hadith, Prophet Muhammad ﷺ recommended that a person should carefully select his or her mate. This hadith implicated in the whole range of hereditary traits, including character and disease. That's all from our group. Thank you.